Good evening. Can you hear me? Can you hear me? Yes, right. Yeah. Send me message. Audible. Network is low. Let me check. The thing is heavy rain today. How about now? Is it same? Now okay. Now okay, right? Udanya? Now okay. Okay, we're discussing about the extraction method. The extraction method completed. Okay, our today lesson separation and identification. For separation and identification, I told we can use three main methods. The main principle or technique we called as chromatography. Chromatography is the technique. Chromatography. 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 Chromatography is the technique. Chromatography is a technique we can use to separation and identification. Yeah, last week we discussed about extraction methods. What are the types of extraction methods? Extraction methods, do you remember? What are the types of extraction methods? Names. What is the first one? Solvent extraction. Then solvent extraction, again two types, no? Simple solvent extraction, that means batch method, and continuous method that we called as Soxhlet extraction. Good. What else? Extraction by pressing with wax. Extraction by pressing with wax. And what else? Extraction by pressing with wax. And finally distillation. Distillation, we have three main methods. What are they? Simple distillation, steam distillation, and fractional distillation. Simple distillation, steam distillation, and fractional distillation. Do you remember what is the I told solvent extraction or Soxhlet extraction? That means both same. Solvent extraction we can't use for thermal sensitive compounds. That means volatile compound, essential oil. We can't use solvent extraction, right? Because in solvent extraction we have to heat. Whatever batch method and Soxhlet, both continuous method, we have to heat into high temperature. In high temperatures, these volatile compounds will be vaporized. Therefore, we can't use thermal sensitive compounds. Soxhlet extraction by Soxhlet extraction method, we can't use. But placing with wax method, it is okay, not heating. It's heating only in final step, very slowly heating process, very low temperature heating process. Therefore, it's not more disturbance, no more damage. And finally, what is the best method for essential oil extraction? Steam distillation. Steam distillation. Remember, steam distillation. They are key points. Always MCQ papers asking. Last exam paper also there, right? This type question. Soxhlet distillation is the best method for essential oil or volatile compounds. Why? In distillation process, they vaporize and again cooling and condensation. Then we can collect after cooling, right? It has a cooling process, but in solvent extraction, they directly vaporize. Not like distillation, it has a specific mechanism to again cool down by condensers. Therefore, remember, more than simple distillation, steam distillation is more suitable, and the crude product is more purified in steam distillation. In steam distillation, I think you can remember what's the difference between steam distillation and simple distillation. Simple distillation means the plant material and solvent in the same vessel, same container. They vaporize, then what happen? This solvent compound secondary metabolites dissolve in solvent, and solvent vaporize and go into condenser, cooling system. Okay, remember, more than this simple distillation, steam distillation crude product is more purified. More purified means it's not completely purified. It's comparatively it's purified, because what is the difference? Steam distillation. In steam distillation, it in first container it's only solvent. Solvent. It's only solvent. Then solvent transfer to the plant material container. It's plant material, right? Then plant material contact with solvent vapor. Solvent vapor, volatile, only volatile compounds. What happened? Volatile compounds vaporize and they transfer with this vapors, and again condensing and collecting, right? Condensation and correcting, right? Therefore, it's more purified. I got up to now? Okay, that's last week lesson. Clear? Any doubt from last week lesson? Send me message. Do you have any doubt from last week lesson? Any doubt up to now? You can ask now. Sarmia, Fatima, Udanya, any doubt? Extraction methods, okay, right? Extraction methods, done, right? Kabir, extraction methods, okay. I have sent you MCQ marks. I will send you for final marks tomorrow evening. Tomorrow evening. Har. Let's move into our separation and identification process. Okay, now I have extracted crude product. The final product of extraction, the crude product. Crude product mean separated impure solution, not purified solution. Okay, that's the final product of extraction. Har. It's just like a story. මේක නිකන් කතාවක් වගේ මතක තියාගන්න පුළුවන්. හරිද? It's just like a story. Hari. Chromatography mainly three main types again. Extraction also three main types. Chromatography also three main types. Okay, what are the types? The first one, paper chromatography. Paper chromatography. The second one, thin layer chromatography, TLC. The final one, column chromatography. Column chromatography. Okay, remember chromatography techniques mainly three types. That means separation and identification methods. We have three main methods: paper chromatography, thin layer chromatography (TLC) method, and column chromatography. Column chromatography. Hurry. Let's go into lesson. Very simple. Hurry. I will explain one by one, step by step. You have to remember as a story, or you can make a very short note. Now you all have tubes, no? Udanya? You all have tubes, natural products, and you have fluid mechanism and polymer acid. Am I correct? හැමෝම ගාව තියෙනවා natural products, polymer and fluid mechanism. Okay, next month I will send you another tubes. No, next month you have 4 tubes. Cell structure, environment chemistry, practical guide and ICT part. ICT part. ඔය ටියුට් එක දුන්නම ඉවරයි. That's the end of your syllabus. හරිද? Okay. Okay, let's move into our first method, paper chromatography. Paper chromatography. Hari. I will explain very basic level, very simply step by step. Please make sure to make a short note and remember as a story. Ada කතාවක් විදියට like a story you can remember. Okay, paper chromatography. Paper chromatography. Paper chromatography. Okay, for paper chromatography, as first step, you have to prepare a solvent chamber. You have to prepare the solvent chamber. As solvent chamber, you can get a beaker or jam bottle or whatever container is the solvent chamber, right? Solvent chamber. You can select a beaker or jam bottle size beaker or whatever glass container as solvent chamber, right? It is a solvent chamber. And we have to add suitable solvent that depend on the polarity, right? Normally we can select ether, benzene or dichloro what's the name? Benzene, ether, dichloromethane, yes, dichloromethane. Whatever suitable solvent we can select, and dichloromethane, and add only 1 centimeter height, right? 1 centimeter height. These measurements very important. What is the first step? Select a suitable solvent chamber and add solvent, suitable solvent up to 1 centimeter height. Up to 1 centimeter height, this is suitable solvent. Suitable solvent. Solvent. Hari, the first step is done. I selected a beaker or whatever solvent chamber, glass vessel, and add solvent, suitable solvent up to 1 centimeter height. Up to 1 centimeter height. Remember. Second step, we have to close this container, close this solvent chamber. Normally for this close, for cover the chamber, we can use a watch glass. Watch glasses in laboratory. If not, we can use a glass plate. Glass plate or watch glass we can use to cover by watch glass. Watch glass. Okay, the first step is done. First step is done. After that, we have to keep covered 20 minutes. Remember, 20 minutes we have to keep this solvent covered by watch glass. I got first step is done. Make a solvent. We have to get beaker and add solvent up to 1 centimeter height. The volume is doesn't matter. The height is important, right? We have to maintain 1 centimeter height solvent level. Solvent level 1 centimeter height. Then cover by watch glass and place 20 minutes in a side. Understood up to now? Understood? Fatima? Yenul? Okay, this is a solvent. Hi. Now solvent chamber is ready to chromatography technique. Solvent chamber is ready. Now, in laboratory, there is a specific paper type that we called as Watchman number 1. This name's very important, right? Watchman. Watchman is a scientist actually. Watchman number 1. Watchman number 1. Chromatography paper. Chromatography paper. Chromatography paper. Watchman number 1 chromatography paper. Okay, we have to get Watchman number 1 chromatography paper, right? Normally its dimension, very important, eh? Normally its dimensions 8 into 4. 8 centimeter height and 4 centimeter width. 4 centimeter width. Okay, what is the name? Practice. Watchman number 1 chromatography paper. Watchman number 1 chromatography paper. Normal dimensions, it is not it's not required to precise accurate, but approximately this size. This is size 8 centimeter height and 4 centimeter width, right? Okay. Hurry. Next step, you have to get very sharp pencil. Sharp pencil like a gun door. Sharp pencil and draw the solvent front line. Sorry, draw a line like this, right? pencil එකනේ අඳින්න ඕනේ. හරිද? You have to get a sharp pencil and draw a very sharp line 1 centimeter 1.5 centimeter above the bottom line. 1.5 centimeter above the bottom line. Clear? 1.5 centimeter above the bottom level, we have to draw a very sharp line. This line we called as baseline. Remember, it's we called as baseline. Baseline. And after that, using same pencil, we have to draw a same type line. Pencil එකෙන් අඳින්න ඕනේ. Same type sharp line front 1 centimeter below the upper end. 1 centimeter. Yeah, 1 centimeter. 1 centimeter. These dimensions very, very important, right? 1 centimeter below the upper end. This line we called as solvent front line. Solvent front line. Solvent front line. Okay. Are you clear up to now? Are you clear up to now? First, what I did, I got a solvent chamber and add solvent up to 1 centimeter height and cover by glass plate or watch glass. Keep 20 minutes in a side, right? Then I got watchman number 1 chromatography paper with 8 to 4 centimeter dimensions. Then I draw the baseline 1.5 centimeter above lower end, and solvent front line, draw using same pencil, draw the solvent front line 1 centimeter below the upper end. Understood? Samya? Next step. Now we already have this crude product, the separated crude product from the extraction. Previous whatever solvent extraction or Soxhlet extraction or whatever, distillation or pressing with wax method or whatever, you got crude product solution. Okay, think this is a crude product solution. Extracted product, right? Extract karapu ekේ product එක අපේ final product of extraction. This is a final product of extraction. Okay, what is the purpose of this, doing this chromatography technique? I want to confirm our wish compound, our required compound of this plant extraction, that means crude product. I want to confirm, is it available in this solution or not? Sometimes it is not available. Ek plant එකත් එක්ක අයින් වෙන්නත් පුළුවන්. It can be waste with plant material. Therefore, I want to confirm this crude product, whatever required secondary metabolites contain or not. That's why we call as its identification and separation method, right? Okay. For next step, you have to get a glass rod. Do you know glass rod in laboratory? Glass rod කියන්නේ වීදුරු කූරක් මෙන්න මේ shape එකේ තියෙන. It's a glass rod, right? Glass rod. Okay. After that, we can get a small sample using glass rod. මේක මෙහෙම දාලා මේක dip එකක් එනවනේ. Solution drip එකක් එනවනේ. බිඳුවක් මෙතන ලැබෙනවා. This drip we can place on this baseline. On the baseline, remember. Baseline, we can make a sample using glass rod. Crude product sample we can place on the glass rod. Okay, that is a crude product sample. Think it is A. A is crude product sample. मैं आगे गत्ता sample. A is crude product sample. Okay, now for identification, think I'm going to identify vasicine from Adathoda plant. Okay, vaccine tama then man check කරගන්න යන්නේ. This crude product contain vaccine or not? තියනවද නැද්ද කියලා බලන්න යන්න. හරි. Then in laboratory you have to collect purified vaccine sample as well. Purified vaccine sample. It's only vaccine without impurities. Okay, that we called as control sample. මම එයා C කියලා දාන්න. Control sample. What's purified sample? Purified secondary metabolite sample that we call as control sample. Control sample. I got up to now? Up to now, okay? Kabir? This in laboratory vaccine, cinnamaldehyde, citronellol, they have control samples. Control sample mean purified, already purified secondary metabolites compound. Eken drop එකකුත් using same glass rod after washing glass rod, same control sample required purified sample also we have to place on the baseline. And we have to label them. We have to label her. Now the chromatography paper is ready. And the solvent chamber also now ready after 20 minutes. After 20 minutes, solvent chamber also ready. Okay, now there was an exam question. What is the purpose of keep 20 minutes, close this solvent chamber? Okay, I will explain the practical. You can think the answer for that. Well, hitan answer I will ask at the end of the practical. Okay, after that, we can open this, we can get the solvent chamber and solvent chamber. Okay, this is a solvent chamber now. 1 centimeter after 20 minutes, this 1 centimeter solvent level, and just open this, make open karap gamam. Just after open this container, solvent chamber, we have to place the chromatography paper inside like this. Okay, this is the baseline and this is solvent front line. Baseline and solvent front line. You can see they are the crude product sample. This is a crude product sample and this is a control sample. A and C. Hurry. What I did after 20 minutes, just open the solvent chamber and place the prepared chromatography paper with samples inside the container, inside the chamber, right? Now this is the container that we call solvent chamber. This is the chromatography paper and they are the samples. This is crude product sample, and this is the control sample. Control sample mean purified whatever control sample. Right? Okay. Now what happened? If you observe carefully, now we can see the solvent front means solvent layer is flowing through these holes of the paper. We can observe the solvent front means solvent absorbed to this paper and going through the capillary action that we call as capillary action. You can understand capillary action. Think if you got glass, water glass, and you can dip the tissue paper. Then what happened? the water is flowing through this tissue paper, right? That we call as capillary action. Capillary action. Capillary action. Solvent is flowing through the holes of this chromatography paper that we call as capillary action. Capillary action. Capillary action. I think BST students already know the capillary action is available in soil as well, no? Soil like a capillary action. Not only that, these plants absorb water due to capillary action, no? From plant roots. Am I correct, Fatima? Capillary action. Okay. Now what happened? We can see, we can observe the solvent level is increasing through this paper due to capillary action. And when the solvent front reach to the solvent front line, we can get out to the solvent, sorry, chromatography paper, we can get out from the chamber. Okay, this is a chromatography paper now. This is a baseline and solvent front line. Okay, solvent front line, and this is the crude product sample, and this is the control sample. Okay, now I have get out from the, when the solvent front reach to the solvent front line, we can get out this chromatography paper, right? We can get out chromatography paper from the chamber, right? Hurry. Actually, if you observe in your naked eye, any difference we can't understand. We can't observe any difference. We can't observe any difference. But if we can use chemical reagents, coloring agents, or we can use UV light to observe these variations, observe these compounds. Then we can see, if you use UV light, we can see this control sample is purified, no? Therefore, it has only one compound. Only dot. This crude product is like this. It's contain lot of compounds. It's contain lot of compounds like this. According to the weight of compounds, they separating like this. According to the weight, because these compounds flowing to the solvent, flowing to the upward with solvent, and their position depend on their weight. Low density particles go to this level, and high weight particle, low weight particles go to this level, and high weight particles retain here, right? The control sample also, the distance depend on the weight of this control sample. And yeah, you can observe these dots compounds by using UV light. UV light. Okay, this is the story. Any doubt? Any doubt? This is a story of chromatography, paper chromatography. Okay, I'll revise again, step by step again. Hurry. In first time, do you have any doubt? You can ask me, then it is easy to explain again. Hurry. I'll give you 1 minute. Again, revise what we discussed and steps. And if you have any doubt, you can ask me. Any doubt? Okay, let's revise again. Now imagine as a make a story එකක් වගේ හදා ගන්න ඔළුවේ. Then it's very easy to remember. Please make an imagination in your mind like a story. Like a story. Hari. What's the first step? Prepare the solvent chamber. We have to select suitable beaker and add solvent up to 1 centimeter height. Right? Suitable solvent up to 1 centimeter height and close by glass plate and keep 20 minutes rest. Right? And next, get the watchman number 1 chromatography paper with 8 to 4 centimeter dimensions and draw the baseline 1.5 centimeter above the bottom end. Draw the solvent front line 1 centimeter below the upper end and place samples, crude product sample and control samples on the baseline using a glass rod. Using a glass rod. Right? After 20 minutes, this prepared chromatography paper carefully placed inside the chamber. Inside the chamber. When the solvent front reach to the solvent front line, solvent chromatography paper get out from the chamber and observed by UV light. Then we can observe these colored dots. Colored dots. Control sample normally it's contain 1 dot because it is already purified, but crude product contain lot of compounds. It is impure product, therefore it's contain more than 1. It is possible to have more than 1 compound. Clear? It's a beautiful story, right? Udanya, who is absent today? Today, absent mean very important parts missing. Hari? Kabir? Yenwal? Fatima? Salmian? Amina? Okay, that's the story. Very simple. Paper chromatography. Okay, now can you explain? Can anyone explain what is the purpose of keep 20 minutes close this solvent chamber? Can anyone explain? That was 2017 exam question. What's the purpose of keep 20 minutes close this chamber? Very good, Ravindra. Very good. Others? Kabir, what do you think? Fatima? What's the purpose of keep 20 minutes close the chamber before this practical? Before this practical. Udanya, what's the purpose? ඇයි එහෙම තියන්නේ? You know, what's the purpose? Anyone can't explain? Yeah, Ravindran, correct. Very good. Fatima, what is the purpose of keep 20 minutes close this chamber before this practical? Okay, the purpose, remember, for the saturation, I think you can remember the saturation. Saturation means completely fill spaces. Completely fill. If I got soil, all pores of soil filtered by water, that we call as saturated soil by water. Saturated soil by water. Okay, the purpose of this keep pause 20 minutes to fulfill and saturate this air space of solvent chamber by solvent vapor. Solvent vapor. මෙහෙම වහලා තිබ්බම solvent vapor එකෙන් saturate වෙනවා. The air space is saturated by solvent vapor. Then when we place the solvent chromatograph paper, the solvent front, quickly it is capillary flowing through the paper due to capillary action, due to the solvent chamber is already saturated by solvent vapor. Understood? Okay, that's the answer. Himama ලියන්න ඕනේ. This word's very important. Saturate the air space of the solvent chamber by solvent vapor. Understood? To saturate the air space of the solvent chamber by solvent vapor. By solvent vapor. Okay, that's all paper chromatography. That's all paper chromatography. Any doubt? Okay, go to your tune. Go to your tune. Okay, there are three main types of chromatography techniques. Please quickly note down three types: paper chromatography, thin layer TLC, and column chromatography. Tagalia, paper chromatography, thin layer chromatography, and column chromatography. How to perform paper chromatography? Specially formed Watchman formulate Watchman number 1 chromatographic graph paper used for this purpose. Highlight Watchman number 1. A beaker or jam bottle can be used as a solvent chamber. Add solvent to this height about 1 centimeter and closed by petri dish. Petri dish mean watch glass. Petri dish with a lid force. Saturate the chamber with solvent vapor. Make it answer. To saturate the chamber by solvent vapor. That's the answer, right? Make the size of the colored paper about colored paper mean it's a mistake. It should be chromatography paper. Chromatography paper. Chromatography paper. Chromatography paper. Chromatography paper 18:4. Draw the baseline with a pencil at height of 1.5 centimeter from the lower edge. Right. Draw a sketch of this on another white paper. Using a capillary tube, place a small amount of capillary tube mean glass tube, glass rod. Small amount of impure sample, that means fluid product, on top of the baseline on the graph paper. Place the control sample in same way, right? Place a control sample. There is a solvent chamber, 1 centimeter height. Then the chromatography paper should be placed in the solvent as shown in the figure 2. After 20 minutes, we can place very carefully. When the solvent front rises to about 1 centimeter from the edge of the paper, remove the paper and mark the solvent front with a pencil. Make it in any path. Solvent උඩට යද්දී අරගෙන 1 centimeter වගේ තියදී අරගෙන ඊට පස්සේ solvent front එක අඳිනවා කියලා. Both methods correct, right? Both methods correct. If you want, we can initial step we can draw the solvent front line. When the solvent level come to this level, we can get out, right? If colorless components are present, some visualizing agents can be sprayed into this paper to see them clearly. Then separate components can be clearly seen and mark them with the help of pencil, or they may disappear as a treatment dries. Treatment dry when they disappear. Okay, that's a story. That's a practical. Using whatever sprayers, or we can use spray agents or chemicals, or we can use UV light to visualize these mark points. Understood? Then we can identify these compounds present or not. Identification method I will explain later. Okay, I got up to now the chromatograph practical. Fatima, any doubt? Okay, now I will give you 2 minutes. If you want, you can make a flow chart. You can draw a flow chart of this method. This preparation of solvent chamber and the preparation of Watchman number 1 paper. Finally, place inside the chamber. Then when it is solvent level reach into the solvent front line, we can get outside and observe by visual agents. Observe by visualizing agents. Hari. short note එකක් දාගන්න. paper comma to gap. paper comma to gap. Okay, complete. Okay, now the practical is done actually. Now we have chromatography paper, and if you observe by color visual agents, we can observe some dots, right? PO may control sample only one dot because it is purified, and impure product, crude product sample contain, it consists dot of compound, dot of marks, compounds, right? Okay, now we have another calculation that we called as RF value calculation. RF value calculation, right? RF value calculation. RF value calculation. RF value calculation. RF value calculation. RF value mean we have simple equation. RF value mean compound travel distance. Compound, it's a ratio between compound travel distance divided by solvent travel distance. Solvent travel distance. Solvents travel distance. Compound travel distance divided by solvent travel distance is the equation. Now think RF value for control sample, right? C sample, control sample. මෙයාගේ solvent travel distance 6 centimeter as example. 6 centimeter, right? 6 centimeter, and it's 3 centimeter now. අපි හිතමු මෙයා 4 centimeters. The control sample travel distance 4 centimeter, right? Then you can get the RF value. Compound travel distance 4 centimeter, solvent travel distance 6 centimeter. 4 over 6, that means 2 over 3 is the RF value of control sample. RF value of control sample. Think, මෙයා අපි දාගමු. I can label A1, A2, A3, A4, A5, right? A1, A2, A4, A5. They are crude product samples. Crude product samples. මෙයාගේ අපි distance එක ගමු. think A1 distance, A1 travel distance 5.5 centimeter. A2 travel distance 5 centimeter. A3 travel distance 4 centimeter. A4 travel distance 2 centimeter. A5 travels distance 1 centimeter. Right? Hari. Now I can calculate RF value for all A1, RF value A2, RF value A3, RF value A4, RF value A5, RF value. Now if any RF value approximately comparative equal, then මෙන්න මේ A3 ගත්තොත් A3 travel distance 4, then 4 divided by 3, sorry 4 divided by 6, solvent distance 6, then 4 divided by 6, that value also 2 over 3, 2 over 3. Then I can identify RF value of this control sample and A3 sample same. Then I can identify this Vasicine or whatever identify compound, control sample compounds available in this crude product. It's present. Understood? It's available. The A3 is a compound. How to identify? According to RF value calculation. RF value එක අරගෙන තමයි ගන්න. Clear? Clear? Quickly send update. Fatima, Amina, Sudanya. Clear, right? Habib, Joel, Salmia. Okay, this is the paper chromatography. Paper chromatography. Paper chromatography. Final point. Final point. For all chromatography techniques, we have static phase and dynamic phase. Static phase mean, I will explain. Static phase and dynamic phase. Dynamic phase. Static phase and dynamic phase. Static phase and dynamic phase. Static phase mean it's not moving, but it is help to travel compounds and solvents, but it is not moving. It's help to travel compounds and the solvent. Dynamic phase mean that's helps, that's moving, that's help to travel compounds. Okay, in paper chromatography, what is the dynamic phase? Paper chromatography, what is the dynamic phase? Dynamic phase එක මොකද්ද paper chromatography එකේ? What is the dynamic phase of paper chromatography? It is solvent, remember. Solvent එක තමයි move වෙන්නේ. Solvent is the dynamic phase. What is the static phase? Static phase. Think. The static phase. What is the static phase? Quickly. Okay, you can try. What is the static phase? Remember, holes of chromatography paper, not chromatography paper. Chromatography paper also static, but static phase, holes of chromatography paper. Holes of chromatography paper. Holes of chromatography paper. Right. This is the chromatography paper chromatography. ඒ කියන්නේ paper එකේ තියෙන holes තමයි help කරන්නේ for the movements of molecules. Okay, but they are static, not moving. Solvent also help to for this traveling, compound traveling, but it is dynamic. Okay, that's the story. Amina, this paper chromatography is done. Okay, now you can, I have explained everything paper chromatography on a question එකට ඔයාලට ලියන්න පුළුවන්. Okay, you can try any past paper chromatography question. I have explained everything. I have explained everything for answer any chromatography, paper chromatography question. Okay, let's move into the second one, thin layer chromatography. In past papers, you have a lot of paper chromatography questions, essay questions. Try කරලා බලන්න. හැමදේම කියලා දීලා තියෙනවා. හරි. Go to TLC method, thin layer chromatography. Thin layer chromatography, TLC. Okay, TLC method I can explain within 2 minutes because TLC method same as paper chromatography. TLC mean first step, prepare the solvent chamber. Solvent chamber. Add suitable solvent up to 1 centimeter. Add suitable solvent up to 1 centimeter. Then close the solvent chamber by Petri plate 20 minutes. For saturate the container by solvent chamber. Solvent vapor. By solvent vapor. 20 minutes tibba. Next, you have to get glass plate. Okay, that's only difference. Carefully understand. TLC is the most popular method in chromatography techniques. This is the most popular method. For this, you have to get this type 8 centimeter into 4 centimeter glass plate. Same as this pressing with wax method. It is same. The same, you have to get a glass plate, 8 to 4 centimeter glass plate, right? 8 into 4 centimeter glass plate. And in laboratory, you can find silica gel. In pressing with wax method, we used paraffin wax, no? Paraffin wax. For this chromatography, thin layer chromatography, you have to use silica or alumina gel. It's a gel, right? It's a gel. Okay, normally it's just powder. Make a powder එකක්. If we heat it, it's converted into liquid and it's melted, right? Melted. Okay, now we can add small amount of this liquid silica gel and make a very thin layer. Very thin layer. අපි හිතමු make a plate එකක් කියලා. Think this is a plate now. Now if it is plate, we can add some part of silica gel liquid and make a thin layer on the surface. Make a very thin layer, uniform and thin layer එකක් හදා ගන්න ඕන. Very thin layer you have to prepare on this glass plate. Silica gel or alumina gel. Silica or alumina gel. Very important. Silica or alumina gel. Silica or alumina gel. Silica or alumina gel. Right? Okay, now I have prepared very thin layer. Then we can keep some time for the solidation. In the solidation, in the condensation of this, not condensation, when it is cool, this liquid cool, it's converted into very thin gel layer on the glass plate. Thin gel layer on the glass plate. Hurry. Up to now, okay? Okay, only one step difference. Other all are same as paper chromatography. Okay, then you can again this sharp pencil. You can get again this sharp pencil and draw very thin line 1.5 centimeter above the lower end, 1.5 centimeter. What is the name of this line? Baseline. What is the name of this line? Baseline. Baseline. What is the name of this line? Baseline. Right? Baseline. Then draw another line using same pencil 1.5 centimeter, sorry, 1 centimeter lower the upper end, that we called as solvent front line, 1 centimeter. This name solvent front line already know. Solvent front line. Use sharp pencil. Use sharp pencil, right? Pencil එකක් තමයි use කරන්න ඕන. Understood? Use sharp pencil. Okay, not like paper. When you draw the baseline and solvent front line on the gel layer, you have to be very careful. If it is damage to the alumina or silica layer, it's not flowing compounds through the gel, right? Therefore it should be very careful. මේ baseline එක හරිම carefully අඳින්න ඕනේ. You have to be very careful for draw the baseline. It should be very thin, very sharp line. Very sharp line. Okay, same as now I have crude product, extracted crude product. This is my extracted crude product. I can use a capillary tube or glass tube. Then take a sample and place on the baseline A. And same method, we have to place a control sample as well, purified control sample. Purified control sample. Right? Purified control sample. Okay, after 20 minutes of this, after saturated, okay, we can open the solvent chamber and place carefully this glass plate inside the chamber. Okay, they are the compounds now. Solvent front baseline, solvent front line. Okay, same as due to this capillary action, solvent level gradually increasing through this gel layer. Solvent level, we can observe solvent level is increasing. Now when it is reached to the solvent front line, we can get out this glass plate, and now this is a baseline and compound. This is a solvent front, and if you observe by UV light or visual agents, spreading agents, okay, we can observe like this, same, right? Then we can calculate the RF value and identify compound. Same method. RF value mean compound travel distance divided by solvent travel distance. Okay, any doubt? This is the TLC method. That is the most popular chromatography technique. ගොඩක්ම use කරන method එක. Understood? The only difference for thin layer chromatography use glass plate with very thin silica or alumina gel layer. Other all steps are same. Understood? Amina? Yenol, udanna. Sabir, Fatima. Others, udanna. Yenol. Okay, this is A and this is a control sample. Control sample is purified. It's contain only one compound, but crude product is not purified. Therefore, it contains lot of compounds. According to the weight of this compound, separate while traveling through the J. Right? Okay. Now, my question. There was another exam question. Exam එක අහලා තිබ්බ මෙහෙම. Why maintain 1.5 centimeter height to the baseline? ඇයි අපි 1.5 centimeter maintain for baseline from bottom end? Can you send me? Anyone? 1.5 centimeter. Select for baseline. Kabir. Why? What's the reason? Think. Uh, 1.5 centimeter. Refer this diagram. This is the solvent chamber. This is solvent chamber. And this is the solvent level, 1 centimeter. And this is the chromatography paper. It is 1.5 centimeter. Why? If we only keep 1 centimeter, what's the coming problem? Very good, Rehlan. To prevent the dissolving of place samples with the solvent. Very good. That's the reason. That's why we need to maintain 1.5 centimeter and 1 centimeter height solvent level. Then it has gap 0.5 centimeter. Yes. 0.5 centimeter gap. Then it's prevent dissolving compounds in the solvent. Yes. I forgot. For example, I got only one crude product. No. If you want, we can place more samples on the baseline. Think this is the control sample, then first crude product, second crude product, third crude product. We can have more samples, then control sample only one compounds මේ වගේ මෙහෙම තියෙන්න පුළුවන්. එතකොට අපිට we can identify which crude product contain vasicine compound. එහෙම හොයාගන්න පුළුවන්. Now we can say A crude product not contain vasicine, but B and C it's contain vasicine. Vasicine mean control sample, right? Okay, understood. Final question. In paper production, I told static pace and dynamic pace. What is the static pace for thin layer chromatography? What is the static pace for thin layer chromatography? Static pace for thin layer chromatography. Quickly. What is the static pace for thin layer chromatography? Hitan. Static pace means it's not traveling, but it is help to travel compounds. Helps to travel compounds. Static pace. Quickly. Yenol, Fatima. What is the static pace of the thin layer chromatography, TLC? Udanya? What is the static pace? If not, send me what is the dynamic pace? What is the dynamic pace of chromatography? Thin layer chromatography, TLC. Dynamic pace. Dynamic pace means that helps to travel compounds, but it is traveling. That one also traveling. This phase is also traveling. What is this? Quickly. Kabir. What is the dynamic pace? What is the dynamic pace? Anyone? Quickly. Okay, the dynamic pace is same. Very good, correct. The dynamic pace is same. Dynamic pace. Dynamic pace, solvent. This one also solvent. Any chromatography technique, it's a solvent. It's solvent. Static pace. Now it's changing silica gel. Silica gel, silica gel, silica gel, silica or alumina gel, whatever gel layer is a static phase and dynamic phase. Okay, any doubt, Fatima? Thin layer chromatography? Thin layer chromatography? Yeah, that we discussed. Okay, they are the compounds. They are baselines, solvent front lines, solvent front. Okay, they are the compounds. They are the compounds. Thin layer chromatography TLC. Yeah, this is a TLC technique. This is a glass plate and solvent chamber. TLC chamber means solvent chamber. TLC plate. And this is the final result. Right? Okay. Final steps. Column chromatography. Column chromatography. Hari. Column chromatography. Okay, final topic, column chromatography. Can you hear me a bit? Is there any doubt? Hard. Column chromatography, final one. Column chromatography. Okay, for column chromatography, actually it is not a identification method, it's a separation method. Column chromatography is a separation method. Why we call it separation method? This column chromatography we can use for crude product with large number of particles. Think it is a crude product. Crude product, it contains large number of compounds. Large number of compounds. Large number of compounds mean if we did thin layer or paper chromatography, that is a resulting product. That's the result. Baseline, solvent front line. This is a control sample, and this is a crude product sample. Okay, this is a final product. This is a final product. Then can we identify separately compounds? Can we identify? No, that's the problem. For this type cases, the crude product contain large number of molecules, large number of compounds, secondary metabolites, primary metabolites, large number of compounds. These cases, we can't perform thin layer chromatography or paper chromatography directly. Okay, that's why we're doing column chromatography as a separation technique. It's a separation technique. Very important, right? It's a separation technique. Okay, do you know burette? Pipette and burette? They're not in laboratory. Pipette and burette. Pipette, burette. Normally, how about the height of burette? How about the height of burette? Burette. Do you have idea, Fatima? Burette. Okay, it's 1 meter height. Normally it's 1 meter height. Okay, this is a burette. It's contain a valve here. This is a valve. Valve එකක් තියෙනවා. And this is a open. And the total height 1 meter. 1 meter that we call as burette. Okay, for this column chromatography, we have to select burette and need to be clamped with a stand, connected to a stand and fixed vertically. Okay, this is a burette now. Okay, that we called as chromatography column now. Chromatography column. For this experiment, the burette is a chromatography column. Right? Understood? Very important. Good questions have it. Many number of questions in past papers. Right. Okay. Now this is the chromatography column. Okay. In first step, you have to add a cotton layer. Cotton layer at the bottom of the column. Cotton layer. Right? Then 5 centimeter sand layer. 5 centimeter sand layer. Hari. 5 centimeter sand layer එකක් දාගන්න. Then alumina or silica gel in liquid form we can add 85 centimeter approximately. 85 centimeter alumina or silica gel layer. Alumina or it's a gel layer. Alumina or silica gel layer. Silica gel layer. Right? And additionally, in upside 5 centimeter another sand layer. 5 centimeter another sand layer. Right? That is a column now. That's a column. Okay, this is a problematic crude product. It's contain large number of compounds. Okay, what we can do, we can continuously adding this crude product solution into this column, onto the sand layer, and we can get 5 milliliter small cups with a numbering A, B, C, D, E, F. The number depend on the crude product volume, right? 5 milliliter small cups. 5 milliliter small cups with labeling. Right? Okay, now I am going to add this solution into above sand layer, upper sand layer, and this solution slowly coming through this gel layer and other sand layers, fill into these cups. When it is filled 5 milliliter, again get new second cup and fill. Third cup, fill it. Fourth cup. Okay, until end, we can separate these solutions. Remember, when this solution compounds traveling through the gel layer, they separate according to the density, according to the weight. That means high density particles quickly coming, and low density particles very slowly traveling through the sand layers and uh, sand layers and gel layers. I got. Then we can separate into different solutions. The crude product, according to the weight of compound, I have separated into 6 solutions now. Now I have 6 crude product. Okay, this separated crude product we can use thin layer or paper chromatography separately. Understood? Meva thin layer hari paper chromatography kalla we can identify. It is not an identification method, it's a only separation method. Clear? Fatima, Amina. It's only separation method, not an identification method. Abir? Okay, after this separation, we can again perform thin layer or paper chromatography for the identification and confirmation process. The column chromatography is only a separation method, separation technique. Habir, understood? Amina, Fatima? Okay, now there was an exam question. There was an exam question of column chromatography. What's the purpose of adding 2 sand layers between gel layer? What's the purpose of adding 2 sand layers between gel layer? What is your answer? What's your answer? What's the purpose of adding 2 sand layers between gel layer? Quickly. What do you think? Remember, it is important to the protection of sand gel layer, because if we directly add solution into onto the gel layer, it's coming disturbance, so it's a damage to the gel layer, right? It's possible to damage gel layer. Okay, that's by this sand layer, it's protect gel layer between these sand layers, right? And there was another exam question. What's the purpose of this cotton layer? Cotton layer, what's the purpose? It's prevent travels sand particles into the separation cups. Separation cup එකට sand යන එක avoid කරනවා, right? Okay, they are simple things. Okay, that's the end of chromatography techniques. Okay, you can note down this. This is a cotton layer, sand layer. If you want, you can 5 centimeter, right? Silica or alumina gel, and again sand layer, right? Again sand layer, silica or alumina. Okay, that's story. That's a chromatography is done. Chromatography is done. Any doubt in chromatography techniques? Any doubt? Any doubt? Okay. Final part, purification. Purification methods and pattern. It's only 30-minute lesson. 30-minute lesson that we discussing Friday. And don't miss Friday class. Friday we doing fluid mechanism as well. Fluid mechanism වලට ready වෙලා එන්න tute එක බලලා go through the tute and ready for the fluid mechanism as well. And that's the end of chromatography techniques. Next day after tomorrow, Friday, we discussing purification methods and patterns within 30 minutes and start the fluid mechanism. Okay, do you have any doubt today? Kabir, Fatima, Amina, any doubt today? Okay, please go through and prepare short notes and ready for the next exam. You have again exam on 2nd of June. 2nd of June, Tuesday morning. Okay, I'll send you final marks tomorrow evening and ready for the next exam now. Okay, goodbye. Good night.